With the basics that we have built from the previous video based on the fundamental postulates in switching or Boolean algebra, in this video we're going to see some basic properties by using the fundamental postulates. Those fundamental postulates which we discussed were binary operations, unary operations, and how a switching variable looks, okay, and the properties of it. So now coming to this, the first property we're going to see is idempotency. Let me write it down here. Idempotency, in this we'll see if there is a variable x and if we do an OR operation on the same variable, what is the resultant we're going to have. And if you see a dual of this particular equation, now we will see in detail what is the dual of a particular equation in further coming videos, okay. But for now, let's take, if you have a variable, just keep the variable same, and if you have an AND operation, substitute it with AND operation. If you have AND operation, substitute it with OR operation, okay. And if you have 0, change it to 1. If you have 1, change it to 0, okay. So in this case, you have a variable x, keep it like that. You have a plus, so make it dot, okay. You have x, take x. So these two equations are going to be dual to each other. So now let us see the first one, how it is going to be. So the resultant is going to be x. Why? The basic way of actually proving these kind of identities is by using perfect induction method, okay. Let me write it down here. It's called perfect induction method, okay. The way how we prove this is, if you take x and we're going to have x plus x, right? So we will write x twice. So if x is 0, this x will be 0. If this x is 1, you'll have 1. So if I write x plus x here, 0 plus 0 is what? Logical OR I'm saying, okay. 0 or 0 is 0, 1 or 1 is 1. So x plus x is nothing but x itself, right? So that's how we are going to write it here. So by using this perfect induction method, where you take all possible combinations of the variables or the equation in the left hand side and try to get the right hand side equation proof by substituting actual values. This is a very consistent method, but it is time consuming. So usually we will do, or we will use the basic postulates which we build instead of doing it with perfect induction, okay. So x dot x, if you do the same method, you're going to have x, okay. So if you take the dual of this, you got this. If you take the dual of this, you'll get this, okay. If you are able to find for the one, you'll get for the second one. So this is idempotency. You can understand why it is called like that, right? You are doing OR on same variable, identity variable, you're getting the same. And if you're doing AND operation on the same identity variable, you're getting the same identical variable at the outside, okay. Second property which we're going to see is commutativity, okay. In this, just like usual algebra, if you have two variables, if we can write them x plus y, can we write it as y plus x? Can we? You can try proving it by using perfect induction method, and it is pretty straightforward to say this, okay. And if you write the dual of it, x dot y will be equal to what? Y dot x, okay. Second one is done. The next one is associativity principle, okay. Associativity, okay. In this, if we need to consider three variables, okay. Suppose we have x plus y plus z, okay, and take x plus y and then plus z, okay. So it means first you are ORing these two variables and then you are ORing the resultant with this variable, which will also be written as x plus y plus z. It means first ORing these two variables x, y, and then ORing z is also equal to first ORing y and z and then ORing to x. That's what it means, okay. So if you write the dual of it, x dot y, right, dot z can also be written as x dot y dot z, okay. Dot here means AND operation, okay. So we are done with associativity principle. Next one is complementation. Complementation. Okay, in this, if you have a variable and add its this variable's complement to it, what will be the resultant? Okay, now let us see simply with perfect induction method. If you have x and if you have x bar, what will be the resultant? 0. If x is 0, x bar will be 1, right? Complement of it. So if x is 1, you'll have x bar as 0. So if you add these two, I mean add in the sense it is logical OR operation or logical sum. So we will have x plus x bar as 0, 1 is 1, 0, 1 is 1, right? So the resultant is always 1. Okay, so now let's take the dual of this equation. It is x dot x bar, right? This is equal to, we initially discussed finding the dual of it, replace 1 with 0. If you have 0, replace it with 1, so 0. You can identify it from here. Okay, x dot x bar, okay, and operation 0 1 is 0, 1 0 is 0, so you're going to get 0. Okay, so complementation is done. Next property we're going to see is distributivity property. Okay, in this case we need to take three variables. X dot y plus z can be written as, this operation will it be distributed, okay, here. So we can write it as x dot y plus x dot z. Okay, so in order to find the dual, that equation will also have the same thing. Okay, so if you have x plus, okay, y dot z, this can be written as x plus y, okay, times x plus z. So this is distributivity property. Next one is absorption property. Okay, absorption property. In this, if you have a variable, say x, plus the same variable times some other variable, say y, then what will be the resultant? Okay, now if you write the dual of this, okay, x dot x plus y, we'll see what are the results of these two. So if you try doing that, okay, by using perfect induction method, what we have been doing so far, if you do that, we're going to get, let us do that, x and y 0 0 0 1 1 0 1 1, right? X plus xy. If you do this, you're going to get 0, okay, 0 1 and 1. So if you observe this, this is going to be x itself. So x plus xy can be written as x. So how do we prove this? Okay, so this x plus xy can be written as, okay, again you can take x common, you'll have 1 plus y. You know that 1 plus any variable is going to be 1, right? Because 1 OR of any variable is going to be 1. You can try it out. Okay, so the reason why I'm saying is, if you have a variable like 1, okay, that is going to be fixed, and y variable is there, y can be 0 or 1. If you take 1 or y, you'll have output as 1 plus y, right? So you'll have 1 and 1. You're going to have 1 itself. So you'll have 1. So this can be written as x times 1, which is x. So we can write it as x. And similarly this one, we can write it as x itself. Okay, this is called absorption. It means this x has absorbed this particular term. Okay, and the next one we will see a simple equation which is just like the above equation only, but slightly modified. Okay, if you have an equation like x plus x bar y, what is its equivalent? And if you have a similar one, dual, okay, x times x bar plus y, what is the resultant? Okay, to do this, let me rub this side off. If we take the same equation, I'm going to take it here, x times, okay, x plus x bar y. By using distributivity property, we can write x plus x bar times x plus y, right? So we can write x plus x bar is what? 1, right? We have seen this before. So 1 times x plus y, we can write it as x plus y. So the resultant is x plus y. And if you see the same here, it can be written as x times y. It can be proved easily. X times x bar plus x times y. X times x bar is 0, so 0 plus xy is xy. Okay, so If you like the video, please do subscribe, and thanks for watching.